I built a 3D printed acoustic guitar, and it was cool. But cool wasn't enough. I wanted it to sound like this. So I went down a rabbit hole. I printed new tops, I tested 8 different filaments, and I shaved the braces down until the guitar was terrifyingly close to snapping. It took countless failures, and eventually I came to a design that looks like this. And this isn't even the final form. I ended up using a design that uses 3D printing and this Mylar foil to make a soundboard. But let me show you how I made this, and we can see if this design can sound anywhere close to as good as wood.
First things first, this rubber gasket I used in the last video has got to go. A lot of you commented in that video that it is probably absorbing a lot of the sound and a lot of the vibrations, so let's take it off and test it out. Yep, the gasket's gotta go. I spent most of the time printing new tops because the top actually has the most impact on the sound of the guitar. Printing the tops in multiple pieces and gluing them together had to be making this sound worse. So I bought a printer with a large enough bed that I could print the tops all in one piece. And by the way, I bought this all with my own money. This wasn't given to me by anybody for free, mostly because I'm not cool enough to get those kinds of cool sponsorships. I printed 5 different tops, so I used one that's PLA, one out of PETG, one out of PETG carbon fiber or PETG CF, then one out of wood PLA.
Wait a second, this is just oak colored PLA.
Then I printed a top in wood PLA, and after that I printed one in polycarbonate, but that didn't turn out so well because I don't have an enclosure. Let's do a tap tone test on all of the tops. I mean, it actually vibrates okay.
All right, I thought that the carbon fiber was pretty clearly the best option because if you listen to it, it tends to like ring a long time. Like it has that long decay and it sounds pretty musical, but I'm not really an expert in this, so I'm just kind of going from my gut.
I figured that I should probably be pseudo-scientific about this, so I measured all the tops with my kitchen scale and marked down the weights. I also went ahead and measured the wood top that I created in my last video just to get a reference. Now I've got to figure out a way to measure how stiff the top is.
This is my totally scientific test apparatus. That is definitely not just a bunch of pieces of wood stuck together and a hole for a dial indicator. But what we're going to do is take, got 2 of these big old DeWalt batteries, since I don't have a real weight, and we're going to use those to see how far it flexes.
Again, I start with the wood top to have a control for the experiment. Then I go on to testing all the other different tops and see how much they bend. Wood clearly has a huge advantage over 3D printing. It was both stiffer and a lot lighter. It took a ridiculous amount of time to unscrew the tops of all of these and screw on each different one, but I'm going to compress it down to just a few seconds of sound test for you. Now let's see if wood PLA does something magical by just having wood inside of it.
I mean, I think it's slightly better.
Well, I think carbon fiber wins again, and that made me wonder how much of a difference it would make to make the rest of the guitar body out of carbon fiber filament. Now, I also had to make sure to put a clear coat on top of this so that I didn't get any of those little carbon fiber fibers all in my skin. But this whole process took forever, so now it's time for a montage.
First, I got to put it back in, then I got to make a new neck. Out of carbon fiber filament and fill it with carbon fiber rod so it's strong. Then I glued a new body together with epoxy. And then it's time to press up all the preps, making sure to glue them in so they stay in strong. Gotta glue the body to the back. Put a clear coat on the whole thing so I don't get carbon fiber in my skin. Give it good to set up and make it's done.
Man, that is still not much better. I was really starting to get frustrated. I thought this would be an easy project to just use different filament or, lower the braces to make this sound significantly better, but it only sounds slightly better than the original. And there's a lot more to acoustic guitar making than I ever thought. This guy is an acoustic engineer who also builds guitars in his spare time. And the first few chapters basically explain why my guitars sound the way they do. It turns out that the most important factor is stiffness to weight ratio of the top. But it's not enough for a soundboard to be stiff. It has to be stiff relative to how heavy it is. The top needs to be able to vibrate freely. And heavy things don't vibrate freely. They vibrate slowly. And when the soundboard vibrates slowly, you get this really deep, dark, and more of a muffled tone. That's exactly what I was hearing in my guitars. Wood has a freakishly good stiffness to weight ratio. Sitka spruce is probably the most common wood that they use for guitar tops because it is so light, stiff, and responsive. There isn't a 3D printed filament that even comes close to the weight to stiffness ratio of wood. So I had to find another way to make the design significantly lighter. The first way I tried to reduce the weight was to remove all the braces out of the PET carbon fiber top entirely. No braces at all, just a 3mm sheet of plastic. That actually got down to 460 grams, which was a nice improvement, but without any bracing, it flexed over 6mm under just one battery. That thing flopped around like a yoga mat. But I went ahead and screwed it on the guitar anyway. Yeah, that's still not it. Okay, I needed the top to be thinner, but I was afraid that that would probably break. So what I ended up doing was scalping the braces as much as possible and using a thinner top. So I made this top only 2mm thick, and I want to be honest with you, I'm pretty terrified. I can hold this in my hands and just feel it flex from the weight of my hands, but it came in at 436 grams. That's not bad, but it flexed over 10mm. For reference, wood was under 1mm of flex. We were definitely going in the wrong direction. And then I broke a string, but luckily Stringjoy had sent me a couple of sets of strings for this project. So I swapped in this fresh set of Stringjoy strings, and when I played it back, it actually sounds a lot better. But here's the problem. I'm not sure how much of the effect the Stringjoy strings had versus the newer top. So I guess thanks Stringjoy for having really good sounding strings that probably messed up all of my results. And thanks for this sweet shirt. Okay, back to the pseudoscience. Even accounting for the strings, the Scout Braces top was just too floppy to sound right. I gotta try something way outside the box. And that's when I started thinking about geometry. What if, instead of solid walls and flat braces, I used a honeycomb pattern. Honeycombs are structurally strong, and let's be honest, they look freaking sweet. I printed a 4mm thick hex top. It came in at just 238 grams. That's actually lighter than the wood top. This might be able to work, but for the top to amplify the sound, you can't have all these holes in it. And luckily, I had an idea for that. I have all these Mylar foil space blankets for my upcoming microphone build, so I glued it on. I measured the stiffness and it came in at 17.7mm of deflection. For context, wood was 0.94mm. My honeycomb top was flexing almost 20 times more. It was basically a trampoline, but I went ahead and tried it anyway. Sadly, it was not strong enough to hold the string tension. So I tried a 6mm hex top. This was a little stiffer at 10.5mm of deflection, but also a little heavier at 355 grams. Unfortunately, 6mm was still flexing too much, but it was close enough that I could try and test out the sound. Unfortunately, it still didn't sound amazing, which is too bad because this version looked super cool. I'm not gonna lie, at this point I was feeling pretty down about the project. I was able to make this guitar sound significantly better, but still didn't sound anywhere near as good as a wood guitar. And the hex tops were just way too floppy. But I've got one last idea to try before I give up. I'm gonna go back to this 4mm thick hex top with my Mylar blanket. But this time, I'm adding some X braces to increase the stiffness of the top. Since those X braces really helped guitar tops in the past, I was hoping that maybe it would also be able to help the stiffness of my 3D printed tops. But because of those X braces, this time I had to put the foil on the top. It doesn't look as cool, but with any luck, it'll sound awesome. Okay, here is the moment of truth. That's not too bad. But how does it sound compared to the wood top that I made in my last video? Okay, that sounds significantly better. Oh, it's ridiculous. Well, crap. The wood is just way better. You just can't compete with the stiffness-to-weight ratio of real wood. And if you want to see how this crazy project got started, watch this video.